All right, let's say you were asked to find, or you were asked to graph this model or this exponential function and find all the pieces of information that are off to the right here. Okay, I'm going to walk through these on this example, and then I'll give you one that I'd like you to try on your own. All right, so the first thing is when you look to see where is the variable located, that tells you what your parent function is or what function you're looking at. Okay, so it's not linear, it's not quadratic. You see your variable is actually in the power, so it's an exponential function. You look to see your base is greater than 1, so it's a growth factor model. So the general form that this is modeled after is going to look like this, with a horizontal asymptote at y equals 0. Okay, but let's see what happens to all of these. The easiest thing to work through first is the vertical shifting. Okay, the vertical shift is going to affect the horizontal asymptote. So I'm going to tie those in as the same first step. Okay, so our vertical shift is the transformation that happens outside our function. So inside our function is up here. Wherever the variable is the inside the function. So here on the outside of this function, our vertical shift is going to go what? Down 3 units, which means our horizontal asymptote is going to be the equation y equals -3. So we simply find 1, 2, 3. So here's the horizontal asymptote of our function. Okay, what we can now do is work on this critical point. So this critical point is adjusted by the horizontal shift. Okay, so when we look inside our function, remember that's the value of x that would give you a 0 inside the function. So what value of x would give you a 0 in this expression? 1. So positive 1 means to the right 1. So this point is going to be shifted to the right 1. Okay, now the y value of that point is going to be dictated by reflections and stretching or shrinking effect. Okay, so the way that we can find that is we simply plug this, whatever this horizontal shift is, whatever coordinate relates to that shift, just plug it in and evaluate for y. So when x is 1, we get 1 minus 1 is 0. 2 to the 0 has a value of 1. 1 times 4 is 4. 4 minus 3 is 1. So this point winds up being right here at the point 1, 1. That's going to be a point on our graph. Okay. So when you look at this, our graph has a multiplier of 4. So is it going to be reflected at all? No. So there's no reflection. And since this multiplier is a 4, is this going to represent the shrinking or stretching of the graph? It's greater than 1, so it's a stretch effect. Okay, and so our graph is still going to open up this direction. It's still going to approach this asymptote. And so this is what our graph looks like. It's still going to pass through that critical point. Okay, so right here in red is our graph, and this now allows us to answer the remaining questions about the behavior of the graph. The domain, the lowest y value or the lowest x value, negative infinity to the highest x value, positive infinity. And for the range, the lowest y value is -3. Again, we work from the bottom up. So -3, the highest y value, infinity, it never reaches either of those, so parentheses on both. And then we can look at the left and right behavior. To the left, this graph, it does go down or it falls, but it approaches this asymptote. So we'll call that approaches asymptote. And to the right, it rises or goes up. And so there would be all the different pieces of information you would be asked to find regarding that graph.